Right, often in physics you have to convert from one unit to another, and in this lesson we're going to talk about how to do that. You're going to learn how to choose appropriate conversion factors so that you can change from one unit to another and then carry that through. And then you're also going to understand why using conversion factors in this way is mathematically legal, because sometimes it feels initially like it shouldn't be allowed. So here's our first example. Convert a speed of 100 kilometers an hour into meters per second. So let's start by writing 100 kilometers per hour like this. Because what 100 kilometers per hour means is that if you're to travel at that same speed for 1 hour, you would travel exactly 100 kilometers in that time. And over here, I'm going to write down that what I'm aiming for is meters per second. And I'm going to write that in the same way, instead of with an angled slash like this. So what I now need to do is I need to think about how I'm going to get from these units to these units by canceling. Remember that if you take something like, let's say 3 over 4 and multiply it by 1 over 3, that 3 and that 3 can cancel and you end up with 1 over 4. So the same thing here, what I want to do is I want to put things into the denominator to cancel out with things in the numerator and vice versa. Let me show you what I mean. I want to get to meters from kilometers. So I know that 1,000 meters is the same as 1 kilometer. And I'm going to write that as a fraction because this whole fraction here is actually just equal to 1. So this is just equal to 1, and that means that I can multiply by that. It doesn't change the value at all, and it's mathematically legal because I'm just multiplying by 1. Now I've oriented it this way because I want kilometers in the denominator so that it will cancel with that kilometers. Because I have kilometers here, but I have meters in my target, so I want to get to meters. Now I've actually got my units in the numerator in meters. If I were to multiply across, there's no unit here anymore, and all I've got is meters. But I still have hours in the denominator. So I need to multiply by something with hours in the numerator. Here I've got seconds, but I'm going to build up to that. I know that 1 hour is 60 minutes. So this, again, is also equal to 1. So it's mathematically legal to multiply by it. That hour is going to cancel with that hours. And now if I were to multiply across, I'd have meters over minutes. So now I need to get from minutes to seconds. And I've got minutes in the denominator, so I'm going to need a conversion factor with minutes in the numerator. And I want seconds in the denominator. Well, I know that 1 minute is equal to 60 seconds. So that's what I'm going to now need to multiply across by. Let me give myself a little bit more room. So if I multiply across in the numerator, I have 100,000 meters, and in the denominator I have 3,600 seconds. And if you work that out, you get 27.7 repeat. I'm not going to do sig figs in this one. We'll talk about that in another video. 27.7 repeat meters per second. So I've converted 100 kilometers per hour to meters per second and gotten this result. By the way, just notice that the number got smaller. That's a helpful thing to just keep in mind, that that speeds in meters per second can be smaller numbers and they are still quite fast. I didn't actually show the canceling of those minutes, but you knew, I think, what was going on. Okay, let's do another one. Convert 9.8 meters per second squared. This is an acceleration to kilometers per hour squared. So we write 9.8 meters per every 1 second squared, and our target is kilometers per hours squared. So that's what we want to get to. We know we need to go from meters to kilometers. We've got meters in the numerator, so to cancel that we need meters in the denominator, and we want to get to kilometers. So our first conversion factor is going to have units like that, and now we just fill in our numbers. So 1 kilometer is 1,000 meters, and that's what we're going to multiply. That will cancel out those meters, and now we've got the right units in the numerator. Now, we've got seconds squared, not seconds, in the denominator, and we want hours squared. We're going to do that in 2 steps. So first, we saw above that there are 3,600 seconds in every 1 hour. That's 60 seconds per minute and 60 minutes per hour. But you could do this in 2 steps if you wanted to. I'm just going to borrow what we got from above. Now, if I were to multiply across now, that seconds would cancel with one of those seconds. And now I'd have kilometers in the numerator, and I'd have seconds times hours in the denominator. That's not what we want yet. We need to cancel this other seconds and get one more hour in the denominator. So we're going to multiply by exactly the same thing again, because there are 3,600 seconds in 1 hour. We worked that out in the previous problem. Now, seconds cancels with seconds, and I'm going to end up with hours squared in the denominator. So now it's just a matter of working it out on your calculator, and if you do that and you get 9.8 times 3,600 times another 3,600 divided by 1,000 kilometers per hour squared, that's equal to 127,008 kilometers per hour squared. So that's converting from meters per second squared to kilometers per hour squared. Let's do one more example. Convert 1 meter squared to centimeter squared. Now we're dealing with area. So we write 1 meter squared. Here it's just a single unit, it's not per anything, so we just write it like that. And our target is centimeters squared. Now we know that there are 100 centimeters in a meter, and we want centimeters. This is really in the numerator, right? There's no denominator here. So we want centimeters in the numerator, and we want meters in the denominator. So multiply by 100 centimeters is 1 meter. Again, this is equal to 1. That meter would cancel with one of those. And now we need to do it once more, because if we multiplied across right now, we'd have meters times centimeters. So again, we need centimeters in the numerator and meters in the denominator, and it's 100 centimeters per 1 meter. So we write it this way, not upside down from this. That meters cancels with that, and now I multiply across. So 100 times 100 is 10,000, so 1 square meter is equal to 10,000 square centimeters. So with that approach and a bit of practice, you should be able to convert between any units that you want.